All right, so let's jump right into using long division to convert these rational numbers to decimals. And that's what we're going to keep doing over and over. But we're going to use kind of our hint to know if I'm looking for a terminating or repeating decimal, because if I don't know, I could keep going in my long division for a long time. So remember, what we do is we take our denominator of 8 and we break that up, okay? 2 times 4, 2's prime. Hopefully you remember doing factor trees. 2 times 2. Okay, so remember, if the denominator is only a product of factors of 2 and 5, or just 2, then we know this is a terminating decimal. So I know that negative 7/8 is going to be terminating. So remember, this actually means 7 divided by 8. And don't forget our negative. 7 divided by 8, doing our long division. 8 goes into 7 0 times. We add our decimal point. 0 under the line. 8 goes into 70 6 times. Nope. 8 times, sorry. I was thinking 64, because 8 times 8 is 64. I subtract 70 minus 64 is a 6. Put a 0 under the line, bring it down. 8 goes into 60 7 times, because 7 times 8 is 56. And I really want you guys doing the long division. If you need a calculator to help you with multiplication, that's fine, but don't just divide this in. You practice this. That's 4, 0 underneath. 8 goes into 40 5 times. 8 times 5 is 40, and we get a remainder of 0. So our solution is 0, negative. Look, I know you can't tell, but I actually went back here and looked to make sure there wasn't a whole number if there was a negative sign. So it's a negative 0.875. Always make sure you kind of glance back and look, because you don't want to forget that negative or forget a whole number. Okay? Same thing here. I'm going to look at 16. That's 4 times 4, 2 times 2, and 2 times 2. Okay, all 2's, terminating decimal. 3 divided by 16. 3 divided by 16. Well, 16 goes into 3 0 times. 16 goes into 30 1 time. 1 times 16 is 16. We subtract. 10 minus 6 is 4. 2 minus 1 is 1. 1 0 under the line, 140. This is where if you need to use that calculator to help you with the multiplication, you could. For the sake of time, I'm going to say that's 8. Okay, and 16 times 8 is 48. 6 times 8. 8 times 1 is 8. 9, 10, 11, 12. 128. When I subtract, that's 12. I know it's terminating. That's what this told me. Bring down my 0. 16 goes into 120. I'll tell you 7 times. And I will tell you, I believe that's 80. Nope, it can't be 80. I'm sorry. 112. That's 2, 42. Well, that's a 4. 7, 8, 9, 10, 11. Yep, 112. Then subtract. 120 minus 112 is 8. Add a 0 under the line. Okay, here we go. 16 goes into 80 5 times, because 16 times 5 is 80. All right, so we get, look right here, nothing in front, 0.1875. All right, so a little bit of work, but hopefully it's work we know how to do. Let's look at some more examples. Okay, using long divisions, I got a feeling that we're going to be repeating digits here, because it's shortest sequence of repeating digits. So if I take 9 and I break it down, that's 3 times 3. Anything other than 2's and 5's, repeating. Okay, and I can't forget my negative. So I'm going to go 4, remember this is 4, divided by 9, divided by 9. 9 goes into 4 0 times. 9 goes into 40 4 times. 4 times 9 is 36, yep. Subtract, 40 minus 36 is 4. Add a 0, bring it down, 9 goes into 40. 4 times, 9 times 4 is 36. I'm kind of thinking I'm going to get a repeating thing here, okay? Do not go like this. No. Meaning that bar up there, okay? You want to write it as 0.4, shortest sequence of repeating, you can see here, shortest sequence of repeating digits. We just put the bar over the 4. Going back, oop, it's negative. Don't forget to check for that. Okay. Oh, just a couple more. I look at 5, 6 here. It's negative. I take my 6 and I break it down into 2 times 3. Well, that's a 3. It's something other than a 2 or 5. This is going to be repeating. So I'm going to go 5 divided by 6. 6 goes into 5 0 times. Add my decimal point. 6 goes into 50 8 times. 8 times 6 is 48. That's a 2. Bring it down. 6 goes into 20 3 times. 3 times 6 is 18. Subtract, that's 2. Bring a 0 down. 6 goes into 20 3 times. Oh, I think we found it. Yeah. Okay. But again, don't just throw a repeating sign over here. Rewrite it. 0.83. Since the 3 is repeating, that's what we put the bar over. Double check the original. Oh, negative. Put a negative out in front. Okay. All right, again, just some of those hints so we know what we're expecting when we're doing this. One last example. Problem solving. Eric and 4 of his friends are taking a trip across the New York State Thruway. They decide to split the cost of tolls equally. If the total cost is $8, how much will each person have to pay? Well, how many people are going? Eric and 4 of his friends. That's 5 people. Because you got to include Eric in there. Okay? And we want to know how much each person will pay. We want to know the cost per person. So we are going to go 8 divided by 5. Now 5, my denominator here, is a prime number. This is going to be terminating because it only can be broken into 5. 5 goes into 8 one time. 1 times 5 is 5. I subtract and get a 3. Put my decimal point in here. Add a 0. 5 goes into 80. I'm sorry. No, bring your 0 down. Get distracted when you make a mistake. 5 goes into 36 times. 6 times 5 is 30. We get a remainder of 0. Good. But always make sure we're answering the question being asked. How much did each person pay? Each person paid 1.6. No, each person paid $1.60. All right. So using long division, it's really helpful sometimes if we recognize what the denominators are, because then we know whether to look for a terminating or repeating decimal. Other than that, just use your long division.